You know, we spend so much time talking about the newest consumer displays, OLEDs, 8K, all that stuff.
Right.
But have you ever been sitting on a train or in a busy airport and you look up at the information screens?
Yeah, all the time.
Do you ever wonder how that video signal gets there? I mean, hundreds of feet away with all the vibrations and noise, and it just works.
It's one of those amazing bits of invisible tech we just take for granted, we expect it to be on. But the engineering to keep that signal stable in such a harsh environment,
Yeah.
that's the real story.
Exactly. And that is why today we're doing a deep dive into, well, the backbone of those systems. We're looking at the NTI VOPEX-M12VA-16 industrial VGA splitter extender.
Which is a mouthful of a name, I'll give you that.
Yeah.
But if you can look past the model number, you're looking at a masterclass in what industrial strength really means.
Right, because when I first saw VGA splitter, I was picturing, one of those little plastic dongles you get for your desk to hook up a second monitor.
Not even close.
Definitely not that.
No. Think of this as the combat-ready version of that. Its whole job is to take a video signal from one computer and just blast it out to up to 16 remote monitors, all at the same time.
16 screens. That's a lot. But the spec that really blew me away was the range. I mean, if I try to run a standard VGA cable at home, it gets all fuzzy after, 20 feet?
Oh, yeah. Signal degradation is a huge problem.
Right.
But this system, it uses standard CT5 or CT6 cable, just regular network cable.
Okay.
And with that, it can push the signal up to 600 feet away.
600 feet? That's 183 meters?
That's 2 football fields.
Mm.
It's smart because running those big, thick video cables through a train car or factory ceiling is a total nightmare. Ethernet cable is cheap, it's flexible.
So you can keep the computer, the actual brain of the operation, tucked away somewhere safe and climate controlled.
Exactly, while the screens are out in the wild.
Speaking of the wild, let's talk about the M12 part of the name. I think most of us are just used to regular computer plugs that kind of slide in and hope for the best.
And that's the key. They rely on friction. If you put a standard plug on a train that's rattling down the tracks, gravity and vibration will work it loose. Probably in minutes.
The jiggle factor.
Precisely. The VOPEX here uses M12 connectors. They're these circular plugs, and they physically screw in to lock.
Oh, okay. So they can't shake loose.
They cannot. They're designed specifically for rail transportation for what's called rolling stock.
That makes perfect sense with the rest of the build. I mean, it's rugged steel construction, powder coat finish, and this operating temperature range is just wild.
Yeah, what is it?
It's from -4 degrees Fahrenheit up to 158 degrees Fahrenheit.
So that's -20 up to 70 degrees Celsius. It'll work in an unheated train car in the middle of a Chicago winter or inside a hot metal box in the desert. Consumer tech would just, melt.
But for all that ruggedness, it doesn't seem to sacrifice signal quality. It still supports resolutions up to 1920 by 1440. It even does CD quality stereo audio.
Which is crucial, right? For passenger systems, you need clear text, and you need to hear the announcements clearly. But there's one number on this spec sheet that tells the whole story.
The MTBF.
The MTBF. Mean time between failures.
And what is it for this?
It is rated for 593,095 hours.
I did the math on that. Hold on. That's
No.
over 67 years.
67 years.
Yeah.
It's a staggering number. But you have to think about the cost of failure. If you run a transit system, you cannot afford to send a technician out to reboot a splitter on a moving train. The labor cost alone is insane.
Okay, that context really explains the price tag then. It's listed at $1,875.
Which sounds crazy for a splitter.
Yeah, but for a transit authority, it's actually a bargain compared to the cost of a failure. You're not paying for the hardware, really. You're paying for the certainty that when the train hits a bump, the screen doesn't go black.
And you're paying for the certifications. It has things like EN 50155.
That's the European standard for electronics on trains, right?
Exactly.
Yeah.
You basically can't install something on rolling stock without it. So that process alone adds to the cost.
So when you boil it all down, this whole device is it's about reliability in the middle of chaos.
That's a perfect way to put it. It makes sure that when the world is shaking or freezing or overheating, the message still gets through.
It definitely changes how I'll look at a departure board the next time I'm in a station.
It makes you think, doesn't it? We obsess over the fancy 4K screen, but maybe the real marvel is the invisible, ugly steel box that keeps the signal alive through it all.